Hi everyone, welcome to my YouTube channel. I am Madam Rusmaya. In this video, we are going to discuss tutorial 21, topic nucleus. Okay, question 1. An example of a reaction studied by Boyes and Becker using a beryllium target is helium, okay, alpha particle, helium plus beryllium. So the product is carbon and neutron. So explain the difficulty of detecting neutrons. Okay, the difficulty is neutron has no charge, okay? And hence it produces very little ionization. So when it passes through matter, and also it is not deflected by electric field and magnetic field. So these are the difficulties of detecting neutrons. Okay, question 1b. To detect neutron better, the neutron is slowed down so that it can be absorbed, such as in this reaction. Okay, neutron plus boron. So the products is lithium and alpha particle. How does this help in detecting the neutron? The answer is the ejected alpha particle here, okay, when the neutron is absorbed by the boron. Okay, so alpha particle has a charge, so it will be easier to detect the alpha particle. Okay, next we go to question 2. In the experiment done by W. Boyes and H. Becker, the penetrating radiation emitted was first thought to be gamma rays. However, it was later found that the radiation was not gamma rays. So explain how the possibility of gamma rays is eliminated. Okay, so the radiation knock off protons from paraffin. So the gamma ray first thought it's not possible to be gamma rays because the radiation knock off protons from paraffin. Okay, the momentum of gamma rays is very small, and its ionization is ionizing power is too low to knock protons from paraffin. So it is not possible to be gamma rays. Okay, so next we go to question 3. The neutral atomic mass of nickel is 61.928349 U. Find its mass defect, total binding energy, and binding energy per nucleon of nickel. So mass of hydrogen atom is 1.007825 U. Mass of proton given 1.008665 U. And 1 U is equivalent to 931.5 mega electron volt. So first we are going to find the mass defect. So the mass defect is the difference between the constituent of the nickel, the proton, electron and neutron, okay, minus the mass of the mass of the nickel itself, the atomic mass of the nickel itself, which is this one is 61.928349 U. Okay, the constituent of nickel will be atom. The atom consists of proton, electron and neutron. So from the symbol here, 28 proton plus 28 electron and plus neutron, we can calculate using 62 minus 28. Okay, so 62 is number of nucleon. Okay, so neutral, we know that here is mentioned neutral, so that's why the number of proton and electron is the same, proton and electron. So 28, factor out 28 and we get in bracket multiplied by bracket mass of proton plus mass of electron plus 34. 62 minus 28 is 34 mass of neutron. Okay, minus m nickel. Okay, so for mass of proton plus mass of electron, we can use a mass of hydrogen atom, because hydrogen atom consists of one proton and one electron. So we can use this 1.007825 U. Okay, multiplied by 28. So 28 mass of hydrogen plus 34 mass of neutron minus mass of nickel. Okay, so now we substitute all these values into the equation here, and we get mass defect 0.585361 U. Okay, so the unit, we use unit U for mass defect. Okay, next we are going to find total binding energy. For total binding energy, there are two methods we can use. You can answer in joule or electron volt unit. So if you want to answer in joule, you can use the first method, which is binding energy equals to mc squared. Okay, mass defect times the c speed of light squared. So the mass defect calculated just now is 0.585361, and then the unified atomic mass unit here convert to kilogram. So 1 unified atomic mass is equivalent to the 1.66 times 10 to the power of negative 27 kilogram. Okay, then times the speed of light. So the unified 1U equals to 1.66 times 10 to the power of negative 27 kilogram is given in the constant list. So if you refer to the constant list given here, okay, it is mentioned that 1U is equivalent to the 1.66 times 10 to the power of negative 27 kilogram. So refer to the constant list given in the paper, in the page in the exam paper. Okay, so now the answer is 8.745 times 10 to the power of negative 11 joule. So if we convert this to electron volt, you can divide by the 1.66 times 1.6 times 10 to the power of negative 19. So you get answer in electron volt, and then can convert into mega electron volt. Okay? So to convert to mega electron volt, you divide by 10 to the power of 6. Okay, so but in the question here, it is given one unified atomic mass is equivalent to the 931.5 mega electron volt. So you can get your total binding energy from this one also, the given information here. So the second method, we can straight away use the mass defect times the 931.5. So the answer is 545.3 mega electron volt. Okay, so we use this information given to get total binding energy in a shortcut way, shortcut method. So here is the longer method. Okay, next we go to question. Next question is binding energy per nucleon. So to find binding energy per nucleon, you can see that from this first method and second method, the answer will be slightly different because of the number of significant figures we use. Okay, so because the question given this information, so for the next calculation, we use the second method to calculate the binding energy per nucleon. So the binding energy per nucleon is, this one is for one nucleon. So if per nucleon will be 545.3 divided by 62. So 62 is number of nucleon from the symbol of nickel here. So number of nucleon is 62. So you get the answer is 8.795 mega electron volt per nucleon. So this is the binding energy per nucleon. Okay, now we go to question 4. A copper coin has a mass of 2.8 gram. Calculate the energy that would be required to separate all the neutrons and protons in this coin from one another. So the coin is entirely made of copper atoms. So mass of hydrogen given, mass of neutron, and also mass of copper atom given. Okay, so we use binding energy formula equals to mc squared. So m is the mass defect. So the mass defect is the mass of the constituent of the atom copper minus the mass of the atom copper. Okay, so the mass of the constituent will be proton plus electron plus neutron. So the number of proton is, you can see here the symbol 6329. So that's mean 29 proton plus 29 electron, because it's a neutral, neutral copper coin. So 29 proton, 29 times mass of the proton plus 29 times mass of the electron, plus number of neutron will be 63 minus 29. So this number of neutron. Okay, then minus the mass of the atom cuprum. Okay, so now we can factor out 29. So bracket here, mass of proton plus mass of electron. And this one is plus 34 mass of neutron minus mass of cuprum. Okay, so now mass of proton plus mass of electron is equals to the mass of the hydrogen atom, because hydrogen atom consists of one proton and one neutron. Okay, so now you substitute all the values given here into the equation, and you get the answer. Mass defect is 0.59191 U, and substitute into the binding energy formula. And don't forget the unified atomic mass, convert to kilogram. Times 1.66 times 10 to the power of negative 27, and this is the speed of light. So the answer, the binding energy is 8.8431354 times 10 to the power of negative 11 joule. Okay, but the questions wants the energy that would be required to separate all the neutrons and protons in this coin from one another. Okay, so the answer in mega electron volt. Okay, for this one, we are going to answer it in mega electron volt. So don't round off too early. So we take this many significant. We continue from this from the top one. Divided by the 10 to the power of 6, because we are going to use mega, and then divided by 1.6 times 10 to the power of negative 19, because we want to convert this joule into electron volt unit. So the answer is 552.696 mega electron volt. Okay, so that's the answer. Okay, next we go. Okay, another one. It give here the question give copper has mass of 2.8 kilogram. So that's mean what we calculate just now is for one cuprum atom. But if 2.8 grams, so how many number of cuprum atom there? Okay, so this 552.696 mega electron volt is the binding energy for one cuprum atom. So for total energy required will be multiplied by n. So next problem is to find n first. To find n, so we can use the ratio mass here, mass of the cuprum atom divided by molar mass equals to the number of atom in the copper coin given here divided by Avogadro number. Okay, so you can substitute the mass 2.8 gram, and then molar mass you can see from the periodic table 62.93, and also can refer here. And then n is this one that we're going to find, and Avogadro number 6.02 times 10 to the power of 23. So you get this value, number of atom in the copper coin of mass 2.8 gram here, and substitute into this one, and the answer is 1.48 times 10 to the power of 25 mega electron volt. So that's the answer. Because the questions one, calculate the energy that would be required to separate all the neutrons and protons in this coin. So that's what this is for number of atom in the copper coin that has mass 2.8 gram. Okay, so that's the answer. Question 5. It is given that the mass of atom ferrum is 55.934939 U. Calculate the total mass of the constituent particles of ferrum atom and explain the discrepancy between the total mass of the constituent particles and that of the atom. And B, find in mega electron volt the binding energy per neutron of ferrum. Okay, for question A. Okay, total mass will be here constituent means proton plus electron plus neutron. So that's the constituent particles of ferrum atom. So we have 26 from the symbol here, 26 proton plus 26 electron. So multiplied by the mass of proton and plus 26 times the mass of electron. And this is number of neutron. So number of neutron will be 56 minus 26. And the mass of proton and mass of electron is we can use mass of hydrogen, but the mass of hydrogen here are not given this time. So you are given mass of proton, so you can multiply by the mass of proton plus 26 times mass of electron. So mass of electron also given, so mass of hydrogen atom not given, so we can use separately these two. Then plus the 56 minus 26 is 30 times the mass of neutron. Okay, all this given in the question. And the answer is 56.463390 U. Okay, for question, okay, now we compare these two values. They are not almost the same, right? So that means there is a mass defect in the mass of the atom ferrum itself. Times compared to the mass of the constituent particles. So the difference between these two is called mass defect. And this constituent particles, the total of the mass of the constituent particle is larger than the mass of the atom. Okay, so the protons and neutrons are in a lower energy state than when they are separated. Okay, so this is the explanation from the question. So why the value is larger for the total mass of the constituent particles. And why? Because the protons and neutrons are in a lower energy state than when they are separated. Okay, now we go to question B. Okay, find in mega electron volt the binding energy per nucleon. So binding energy is mc squared. So for per nucleon, we divided by nucleon number. So the nucleon number will be 56. The mass defect calculated just now, we convert to joule, right? Convert to joule. Okay, we are going to answer in mega electron volt. So we are going to convert to mega electron volt. So we divide by 10 to the 6 and then divide by 1.6 times 10 to the negative 19 for the electron volt. And the mass is in unified atomic mass unit. So we need to convert to kilogram. So convert to kilogram because this is mass, M. Okay, so we need to convert to kilogram. So be careful of the questions. What's the questions one? Then the C is speed of light. Okay. Then the atomic mass number of nucleon here will be 56. Okay, number of nucleon. So we get binding energy per nucleon is 8.81 mega electron volt per nucleon. Okay, that's all for tutorial 21 and see you in the next tutorial.